Hi, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this video, I would like to present some problems on solutions of first order and first degree differential equations. There are so many methods to solve the first order and first degree differential equations based on the given differential equation. We have several methods, and in this video I would like to solve some problems. So which method is applicable to which problem and how to solve the problems, that we will see in this video. So now I would like to solve the following differential equations. Number 1, y dx plus x dy of x cos y by x is equal to x dy minus y dx of y sin y by x. Second one, dy by dx is equal to x minus y by x plus y. Third equation, 1 minus x square of dy by dx plus 2xy is equal to x into square root of 1 minus x square. Fourth equation, x square xy square minus e power 1 by x cube of dx minus x square y dy is equal to 0. Fifth differential equation, x dy by dx plus y is equal to y square log x. And sixth equation, dy by dx is equal to 4x plus y plus 1 whole square. You can observe that all the equations are first order and first degree differential equations. So you can observe that in all the equations we have dy by dx term only. That is the first order derivative, and the power also 1. So all equations are first order and first degree equations. So we have several methods to solve these equations. The methods already we have seen in the previous videos. So if the equation is possible to separate the variables, then we can use variable separable method. And sometimes if the equation is a homogeneous equation, then we can solve it by using y is equal to vx substitution. If the equation is exact equation, we check the condition dou m by dou y is equal to dou n by dou x or not. And if it is exact, then we write the solution integral m dx, treating y term as constant, plus integral the terms of n not containing y terms into dy is equal to c. Similarly, linear differential equations of first order. An equation is of the form dy by dx plus p of x y is equal to q of x. So if the given equation is in this format, we have one solution, y into e power integral p dx is equal to q e power integral p dx dx plus c. That is linear differential equation solution. The last one is Bernoulli form. We have different methods based on the given equation. What is the Bernoulli form? Dy by dx plus p of x y is equal to q of x into y power n. So this is the Bernoulli equation, and this can be solved by reducing the equation to linear differential equation form. So you can apply any model if it is applicable. Now I see some problems, how to identify which method is applicable to the given equation and how to solve it. And that I will show in this video. So the first problem is y dx minus x dy of x cos y by x is equal to x dy minus y dx of y sin y by x. So first I would like to write the equation in the form dy by dx is equal to some function. Here the coefficient of dx is xy cos y by x, and here also dx term, here also dx term, plus on writing left hand side xy sin, or clearly it is y square, on writing right side y square y square sine y by x of dx. This is the dx coefficient, and dy coefficient. Here the dy coefficient is x y sine y by x, and here also dy coefficient on right hand side it will give plus sign x square cos y by x of dy. Or I can write this equation as dy by dx is equal to dx right on this side and this function right on the left hand side. Then you'll get xy cos y by x plus y square of sine y by x by divided by. So this term will come in the denominator xy sine y by x plus x square of cos y by x. So this is the equation. So after writing this into the form dy by dx is equal to function of xy. And clearly the right side function is a homogeneous function of degree 0. By putting xk, kxy, ky, then you'll get kx, ky, k square xy. This will be the homogeneous differential equation. So when there is a homogeneous differential equation, we can solve this equation by taking the substitution y is equal to vx, so that the entire equation will be reduced to the variable separable form. So if I put y is equal to vx, then what we will get dy by dx is equal to v plus x dv by dx on differentiating with respect to x. V x cons differentiating on 1 plus x into on differentiating v with respect to x, it is dv by dx. Then equation 1 reduces to 1 implies 1. What will happen? Dy by dx will gives v plus x dv by dx is equal to, so on the right hand side x and y is replaced by vx, and cos y by x that can be written as v y by x. Y v by x means y by x is can be replaced by v. So here y by x is replaced by v plus, so what I can write here, v square x square, and this is also sin v notation, denominator lo by, in the denominator you get x, y same vx, and it is sin v, sin y by x will be sin v plus x square same as x square, and this is cos v. So here x square is common term in the numerator, then you will get v cos v, and taking out x square outside you will get v cos v plus v square sin v. So x square on taking outside you will get this term. In the denominator also x square take outside, then v sin v plus cos v. So x square cancel. On the left hand side v plus x dv by dx. So now on writing v on the right hand side you will get x dv by dx is equal to, now I am continuing, x dv by dx is equal to, so what is the right side function? V cos v plus v square sin v, and writing v right hand side you'll get minus v. So that is x dv by dx is equal to, so the right hand side LCM v sin v plus cos v, in the numerator it is v cos v plus v square sin v minus v into this term, that is v square sin v minus v cos v. So on taking LCM and on multiplying we'll get this one, or v square sin v gets cancelled, and v cos v. So here I can write v cos v, this is v square v sin v plus cos v, and this is v cos v plus v square sin v. Here the problem may be plus x dy by dx, then it will get x dy means minus of x square. So this is minus v cos v, then it will be plus v cos v. So the denominator, the problem is there is a small change. The problem will be x dy, then only this will be, in the denominator will get minus x square cos y by x, and this is v sin v minus cos v, and this will be v sin v minus cos v, and this will be plus v cos v. Then it will be 2v cos v. In the denominator you will get v sin v plus cos v. This is x dv by dx. Or I can write, now you can separate the variables. How I can separate the variables? This is complete, right side is v term, and here there is x term and dx only. So now on separating the variables, I can write v sin v plus cos v by 2v cos v of dv is equal to dx by x. So now on the left hand side, I can write it as, on separating, on dividing each term, v sin v by 2v cos v. That means 1 by 2 sin v by cos v tan v plus 1 by 2v of dv is equal to dx by x. Now the problem is reduced to variable separable form. Now on integrating, what is integrating? Integral 1 by 2 tan v dv plus integral 1 by 2v dv is equal to integral dx by x plus log c. So clearly it is in variable separable form. On integrating, you will get the solution. So half into integral tan v, that is log secant v, first integration term, 1 by 2 in of 1 by 2, here it is 1 by 2 of log v is equal to, on the right hand side, log x plus log c. Or I can write this is log root secant v, that is secant v whole power 1 by 2 plus log v power 1 by 2, log root v is equal to log cx. Or I can write it as log m plus log n notation. It is log m into n, that is root v of root secant v, this is equal to log cx. So on deleting log, you'll get v secant v is equal to c square of x square. But what you can replace v is y by x. Initially you have taken y is equal to vx or v is equal to y by x. So on substituting v is equal to y by x, finally you will get the solution y by x of secant y by x is equal to c square x square, which is the required general solution of the given differential equation. Here there is a small problem in the writing the problem. So this is the plus sign. So this is printed as a minus sign, so that the denominator will be minus, and so that the equation reduced to variable separable form, and you can find the solution. The solution is, this is the solution. So this is the application problem of homogeneous differential equation. Similarly, we see some another problem. How to solve dy by dx is equal to x minus y by x plus y. So to solve this, we can go for homogeneous method, or you can go for the method exact equation method. So you can write it as mdx plus ndy is equal to 0, and we check whether the given equation is exact or not. If it is exact, you can write the solution. If it is not exact, you have to find the integrating factor and find the solution. Now I rewrite the solution. How I can rewrite? X minus y of dx minus of x plus y dy is equal to 0. Just I am writing this is in the form, this equation is in the form, what is the form? General form, m dx plus n dy is equal to 0. So here what is m? M is equal to dx coefficient, that is x minus y here. And what is n here? Dy coefficient, that is minus x minus y. Then dou m by dou y, the partial derivative of m with respect to y, that is equal to minus 1. X 0 because it is differentiating with respect to y. X term treat as constant, this is 0 minus 1. Similarly, what is dou n by dou x? So how you can write dou n by dou x? The partial derivative of n with respect to x. That is also minus 1 because second term is 0, y term 0. So these equations are equal. These values are equal means this equation is an exact equation. Dou m by dou y is equal to dou n by dou x. Both are having the same values. That means equation is an exact equation. Now if the equation is exact equation, the solution will be in the form integral m dx, treat y as constant term, plus integral the terms of n not containing x terms. N not containing x terms of dy is equal to c. That is the general solution of the problem. So here, what is m? Here, the solution is therefore integral m. M means x minus y. Already it is there. Dx of dx plus integral the terms of n not containing x terms. Here there is x term and there is y term. So we should omit x term and we should write only the y term, that is minus y of dy is equal to c. Now integrate first term with respect to x, treat y as constant. So the integration, first integral x dx, that is x square by 2. So treat y constant. So y of integral dx. So what we will get is y of x, y into x, minus this is y dy, integration y square by 2, that is equal to c. Or I can write it as x square minus 2xy minus y square is equal to c, or c dash, 2 on writing right side you will get c dash, which is the required solution of the given differential equation. So this equation is a very simple equation. We can apply the exact equation method. So we have to check the condition for exactness. These two are equal. So the equation exact, immediately we can write the solution. So the first problem we have done by using the homogeneous differential equation method. That is taking y is equal to bx. So in this we have taken the condition of exactness and check that condition and it is exact equation, and after getting exact equation we write the solution. Now we see another problem. So in this video I'm going to present some problems. So how to solve different problems using the models, that is the requirement of this video. And here the equation, this is also first order equation. So I'd like to solve this equation by using linear differential equation. That means what? I have to write the given equation is in the form dy by dx plus p of xy is equal to q of x. If the given equation can be expressed in this form, then we call it as a linear differential equation. If it is in this form, then what is the solution? Y e power integral p dx is equal to integral q e power integral p dx plus c. Right? So now I would like to write the given equation in standard form. This is dy by dx plus p of xy is equal to q of x. So divide throughout the equation with 1 minus x square. Divide the equation with 1 minus x square. Then what we will get? Dy by dx, the first term. Second term, 2x by 1 minus x square of y is equal to x root of 1 minus x square by 1 minus x square. What we will get? In the denominator we will get on cancelling root 1 minus x square will get in the denominator. So clearly this is looking like dy by dx plus p of x y is equal to q of x. So this is a linear differential equation of first order in y. Here what is p? Here what is p? This is coefficient of y, that is 2x by 1 minus x square is p. And what is q? Q is equal to x by square root of 1 minus x square. Now to write the solution, our requirement is e power integral p dx also. So we find here I calculate e power integral p dx, that is e power integral 2x divided by 1 minus x square of dx. So the integration, so if you differentiate the denominator, you'll get minus 2x. So I can write it as minus of 2x by 1 minus x square of dx. Now it is looking like f dash x by f of x dx. That means e power minus log modulus 1 minus x square. Or this can be written as 1 by 1 minus x square. So e power integral p dx evaluated, the value I observed as 1 by 1 minus x square. Now I want to write the solution. What is the solution? So y into, now the solution is, now the solution is y e power integral p dx, that is 1 by 1 minus x square is equal to integral q x by root of 1 minus x square e power p dx. Again it is x 1 minus x square, x 1 by 1 minus x square of dx plus c. So this is y by 1 minus x square is equal to x by, what is in the denominator? 1 minus x square whole power 3 by 2 of dx plus c. So to evaluate the integral, I take the substitution method, put 1 minus x square is equal to t. On differentiating, minus 2x dx is equal to dt, or x dx is equal to minus dt by 2. So now the right side integral will minus dt by 2, yes, x dx replaced by minus dt by 2. In the denominator it is a t, 1 minus x square whole replaced by t whole power 3 by 2. Am I right? Integral x dx is replaced by minus dt by 2. 1 minus x square is replaced by t whole power 3 by 2 plus c. On the left hand side, y by 1 minus x square. Now what is the integration? So minus 1 by 2. So I will write the integration here. Integral t power minus 3 by 2 dt. So t power minus 3 by 2 plus 1 by minus 3 by 2 plus 1. So 1 minus 3 by 2, that is minus 1 by 2. 1 minus 3 by 2. So minus 3 plus 2 by 2 minus 1 by 2. T power minus half by minus half. So this value t power minus half by minus half plus c. So these two gets cancelled. And what is our assumption t? T means 1 minus x square. So 1 minus x square whole power minus half plus c is equal to y by 1 minus x square, which is the solution of the given differential equation. So here we have used the method linear differential equation of first order in y. So the method is, first you have to write the given equation in standard form, and then find p, find q, then find e power integral p dx, and then write the solution of the given differential equation. So this is the another problem. Now see the another model. Here what is the problem? Solve the differential equation xy square minus e power 1 by x cube of dx minus x square y dy is equal to 0. So this equation also can be solved in the form m dx plus n dy is equal to 0. Right? So this is in the form m dx plus n dy is equal to 0. Exact equation method. So here what is m? xy square minus e power 1 by x cube. And what is n here? Minus x square y. Then what is dou m by dou y? Dou m by dou y is, this is 2xy and it is 0. Because the right hand side, it is a pure function of x. We are differentiating partially with respect to y. So this is 0, only 2xy will get. And what is dou n by dou x? The dou n by dou x is minus 2xy. This is 2xy and this is minus 2xy. So both are not equal. That means what? The equation is not an exact equation. So then what to do? If the equation is not exact equation, then we made it exact by using integrating factor. That means we have to find a suitable function to multiply this equation so that the equation will be an exact equation. So you have different models to identify the integrating factor. Now I choose one of the method. Now consider 1 by n of dou m by dou y minus dou n by dou x. I would like to find the value of this factor. So what is n here? Minus x square y and dou m by dou y, that is 2xy minus dou n by dou x, it is minus 2xy. That means what? 4xy by minus x square y. Y cancel, x also cancel. It is minus 4 by x. It is a pure function of x alone. We have that model. If 1 by n into dou m by dou y minus dou n by dou x is a pure function of x, then what is the integrating factor? Is e power integral f of x of dx. If the pure function of x is the value, functional value, then e power f of x integral f of x dx, e power minus 4 by x dx. Am I right? This is e power minus 4 log x, or it is e power log x power minus 4, or 1 by x power 4 is the integrating factor of the differential equation. M dx plus n dy is equal to 0. This is in the form m dx plus n dy is equal to 0. And now this is equation number 2 and this is equation number 1. Now multiply equation 1 with 2 so that the equation will become exact equation. So now on multiplying with 1 by x power 4, what you will get? The equation 1 implies. So I will write it is now the equation 1 becomes, after multiplying this equation, we'll get xy square minus e power 1 by x cube by x power 4 dx minus x square y by x power 4 dy is equal to 0. So writing into separate terms, we'll get y square by x cube, that is first term. Second term, e power 1 by x cube by x power 4 of dx, that is the second term. And third term, x square by x square cancel, you'll get y by, what you'll get here is y by x square of dy is equal to 0, and call this is equation 3, and moreover it is an exact equation. So you need not to check about the exact. Already you have multiplied the original equation with integrating factor, and the equation is, this is clearly, this equation is an exact equation. So clearly this is an exact equation. So if exact equation, then write the solution. Then the solution will be integral y square by x cube of dx, first term, minus integral e power 1 by x cube by x power 4 of dx, plus integral the terms of n not containing x terms into dy. So there is only one term which is n and it containing x terms, so there is no such term. Integral 0 dy is equal to c. So there is no term to integrate in the function n. So integral 0 dy. Now y square, integral 1 by x cube. What is the integration? Integral x power minus 3 dx. That is x power minus 3 plus 1 by minus 3 plus 1 or minus 1 by 2x square. Integration x power minus 2 will come in the numerator. Denominator minus 2. So minus 1 by 2x square. Already y square constant. So what we will get? Minus y square by 2x square is the integration. First term. And what is the second term? So here to integrate, we use the substitution method. So how we substitute? Put 1 by x cube is equal to some t. So to evaluate the second integral, put 1 by x cube is equal to t. That is x power minus 3 is equal to t. And differentiating n a power x power n minus 1 dx is equal to dt, or 1 by x power 4 dx is equal to dt by minus 3. So how you can write this value? Minus integral, this is e power t, 1 by x power 4 dx. What I can write? dt by minus 3 plus 0 is equal to c. So clearly, to evaluate this integral, I have used the substitution method. So this is reduced to e power t dt, simple solution. So minus y square by 2x square, already it is reached the function, plus 1 by 3 of e power t. What is e power t? E power t means what? What I have taken? 1 by x cube is equal to c is the required solution of the given differential equation. Here minus 3 in the denominator and it is minus 1 by 3 means it is what we will get? Plus 1 by 3. E power t dt. The integration is e power t, but t is 1 by x cube. So it is replaced by 1 by x cube. The solution will be minus y square by 2x square plus 1 by 3 of e power 1 by x cube is equal to c. So here we have used the non-exact equation and we made it exact by using integrating factors. And we are going to solve different types of problems in first order and first degree differential equations. So one problem has taken from homogeneous, one solved by using linear differential equation of first order, and one solved exact equation method, and one the recent problem is solved by using the non-exact equation and made it exact by using integrating factors. Now I'm coming to the next problem. Solve the differential equation x dy by dx plus y is equal to y square log x. Clearly, this equation can be assumed as a Bernoulli equation because at the right side there is a function y square. So if it is a Bernoulli equation, we have to reduce into linear differential equation by using some process. So I will perform all the process here. Now I write on dividing with x. On dividing with x throughout the equation, I can write the equation as dy by dx plus y by x is equal to y square of log x by x. Just I have divided throughout the equation with x. Now our aim is to reduce the equation to linear form. So first I write the standard form of Bernoulli equation. So this is dy by dx plus py is equal to q into y power n. So it is Bernoulli equation. Now to solve the Bernoulli equation, we need to divide with y square also. we divide. So to make the right side as a pure function of x, we have to eliminate y square. So to eliminate y square, we should divide with 1 by x square and divide by y square throughout the equation. Then y power minus 2 dy by dx plus y power minus 2 means 1 by x, y power minus 1, y into y power minus 2, y power minus 1, and y square eliminated, and it is log x by x. So the right side will become a pure function of x. Now what we have to do is, we have to substitute x power minus 1 is equal to some u, or y power minus 1, sorry. There is no x power minus 1 here. Put y power minus 1 is equal to u. Then on differentiating with respect to x, minus y power minus 2 dy by dx is equal to du by dx. So the derivative is n into a power n minus 1. Because we are differentiating with respect to x, we will get dy by dx into is equal to du by dx. Or what is y power minus 2 dy by dx? That is minus du by dx. Just minus sign will transform to the right side. Now, what is the equation reduces? This equation reduces to what? Y power minus 2 dy by dx is reduced to minus du by dx plus 1 by x. Y power minus 1, that is u, is equal to log x by x, or on multiplying throughout with the equation minus sign, du by dx minus 1 by x u is equal to minus log x by x, and this is a linear differential equation of first order in y, in u, because clearly it is du by dx term and u is there. It is a linear differential equation of first order in u, and this can be solved very easily. Already we know that the solution. How to proceed? Just I will write the equation in the next slide. Now the equation is dou u by dou x du by dx minus 1 by x of u is equal to minus log x by x. Clearly, it is a linear differential equation in u terms. Here what is p? The p is minus 1 by x and q is equal to minus log x by x. And what is our requirement? E power integral p dx also our requirement. E power minus integral 1 by x dx, that is e power minus log x, that is e power log x power minus 1, that is 1 by x is the integrating factor, or this is the part of the solution. Therefore, the general solution, what is the solution? We know that u of e power integral p dx is equal to integral q e power integral p dx plus c. So now on substituting the corresponding values, u e power integral p dx, that is 1 by x, is equal to integral, what is q? Minus log x by x of 1 by x of dx plus c. So this can be solved by using log x into x power minus 2 of dx, and this can be solved by using integrating parts, and you can get the solution easily. Where finally you have to replace u by, what you have to replace u by? U is equal to, finally you have to replace u is equal to y power minus 1. So this is left to as an exercise for the students. Minus log x, am I right? Q is minus log x by x, and it is 1 by x is e power integral p dx. So this will be left as an exercise for the students. So evaluate this and find the solution of the given differential equation. So now I'm coming to the last problem. So this is the last problem. This is also a differential equation of first order and first degree, and this is not able to divide into variable separable form. So we can make it to variable separable form by taking the substitution, put 4x plus y plus 1 is equal to u. Just I will give the hint and you do it your own. Then what you will get? 4 plus dy by dx on differentiating 1 0 is equal to du by dx. Or what is dy by dx? It is du by dx minus 4. So this the equation 1 get in the form du by dx minus 4 is equal to u square. Or what is du by dx? It is u square plus 4. So now it is reduced to variable separable form. The right side is only pure function of u. There is no other terms involved in this. So you can separate the variables. Just on separating, du by u square plus 4 is equal to dx. So now on integrating both sides, integral du by u square plus 4 is equal to integral dx plus c. So it is looking like 1 by x square plus a square dx. That means 1 by 2 tan inverse u by 2 1 by a square plus x square dx. It is looking like 1 by a tan inverse x by a formula. This is x plus c. Then what is u? What is u? Already we have taken substitution. U is equal to 4x plus y plus 1. So tan inverse 4x plus y plus 1 by 2 is equal to x plus c is the required solution of the given differential equation. So we have seen several problems and which are having different models to solve the equation, and I covered 6 problems in this video, and I think it will be helpful for you to solve the first order and first degree differential equations. So in this lecture I conclude my thank you.
Like, share and subscribe. Hit the bell icon for more updates.